All right, welcome back. Geometry, section 2.4, algebraic reasoning. Now, the algebra part of this hopefully is not something that's going to be new to you, but what is going to be new is the fact that you're going to have to give reasons for all your steps. But here we go. So we're going to learn to talk about algebraic properties of equality, using algebraic properties of equality to solve equations. And then we'll also talk about some geometry ones that we'll also do. So here we go. If I just ask you to solve this, many of you are going to add 3x to both sides of the equation. You're going to subtract 2 from both sides of the equation, and then you're going to divide by 9 to both sides of the equation. And then the next one you're going to distribute. You're going to multiply into the parentheses. You're then going to subtract, and you're then going to divide. I ran out of space, but x equals 12. So there's the algebra part, just being able to solve an algebra question. What's new today, or what we're going to talk about, is each one of those steps is a property. If you add to both sides of the equation, if you subtract to both sides, if you multiply or if you divide, those are addition property of equality, or subtraction, or multiplication, or division property of equality. Substitution's a little bit weird. If A equals B, then I can replace A with B in another equation. And then the last one would be the distributive property. If I multiply into a parenthesis, I am distributing. All right, so here we go. I've got a math question that I want to solve algebraically. I'm going to rewrite it just to give myself some space. All right, I'm going to add 4x to both sides. That would be the addition property of equality. And notice I abbreviated there. So I just put add prop of equal. Okay, so the addition property of equality. So I added to both sides. So 7x plus 2 now equals 23. I'm going to subtract 2 to both sides of the equation. Again, that would be now the subtraction property of equality. And then the last one, I'm going to divide by 7, which would then be the division property of equality. More algebra. This time I'm going to multiply into the parentheses. Sorry about that. So I'm going to take -5, multiply it to the first one, multiply it to the second one. That would be the distributive property. Next one, I'm going to add 40, which would give me 70. Adding to both sides, the addition property of equality, and then dividing by -35. W would equal -2, and that would be the division property of equality. So using our properties to explain what we're doing. You get a raise for a part-time job. To write your raise as a percent, use the formula P equals R plus 1 equals N, where P is the previous wage. So I'm going to write that down. P equals R plus 1 equaling N. Solve the formula for R. What is your raise written as a percent when your hourly wage increases from $7.25 to $7.54? Now, I actually, on this one, just plugged it in. So my old P is my previous wage. So $7.25 R plus 1 equals my new wage of $7.54. And I did substitution, allowed me to do that. Then I distributed. And again, my reason is the distributive property. Then I subtracted. I have $7.25 R equals positive 0.29 and divide by 725. I believe it's 0.04. And that's the division property. And so that would be a 4% raise. Now, if they want you to just solve the equation for R, I'm going to do this down here. P R plus 1 equaling N. Instead of distributing, I would divide by P. R plus 1 equals N over P. And then I would subtract 1. So N over P minus 1 would be just solving the equation for R. More properties, and these are properties of equality that we'll use a lot when we start getting into proofs. Segment lengths and angle measures are real numbers, so these properties of equalities are also true when we talk about the length of a segment or the length or the measure of an angle. Now, some of you might look at this reflexive property and say, well, when am I ever going to say AB equals AB, or the measure of angle A is equal to the measure of angle A? Anytime we say something is equal to itself, we're probably doing something about sharing, meaning this triangle and this triangle share this side. And so if you're saying that AB, I was going to use a different color there, AB is equal to AB, it means AB in one triangle is equal to AB in the other triangle. So that's when the reflexive property is used the most, is when two things are sharing something. With that being said, the symmetric property, anytime I want to reverse it, like A is equal to B, then B is equal to A. Anytime you are reversing something around the equal sign, that is called the symmetric property. And then the last one, the transitive property. If A equals B and B equals C, then A equals C. All right. Now, this one's a hard one, and it's not written here on the notes, but I want to know, this is what they want me to try to find, is if angle EBC, the measure of angle EBC, would equal the measure of angle ABD. That's what they want me to know, or try to figure out. And in the picture, I am given that angle 1 equals angle 3. So that's what I'm given in the picture. These two marks tell me that those two angles are equal. Now, I'm going to talk about a property that we have not necessarily talked about right now, and that's angle addition. If I say that angle EBC equals angle 2 plus angle 1. Notice, and I'm going to go over here to my picture now. It's saying this angle plus this angle adds up to the whole angle. The reason you say that, and I'm not giving a lot of space, the reason I would say that is called angle addition. And so I could say the same thing about the other one. I could say that angle ABD is equal to angle 3 plus angle 2. Same reason, angle addition. Now, substitution. I can say, because angle 1 is the same as angle 3, in place of that angle 3, ABD, could equal angle 1 plus angle 2. Now, EBC equals angle 1 plus angle 2. ABD equals angle 1 plus angle 2. So I now can say that angle EBC equals angle ABD. And the reason I say that, this one was substitution, and the reason I can say this is the transitive property. Now, me and my colleagues may disagree, okay? Substitution would also be an option as far as I'm concerned. But transitive property. This one's hard, and it probably takes a picture more than anything else. So I'm going to draw a little picture of a straight line. Here's the park. We're going to call that point A. And here's the shoe store. And we're going to call that point B. Here's the pizza shop. We're going to call that C. And here's the movie theater. We're going to call that D. So as we go through this now, a park and a shoe store and a pizza shop and a movie theater are located in order on a city street. The distance between the park and the shoe store, so this one, is the same as the distance from the pizza shop to the movie theater. Show that the distance between the park and the pizza shop is the same as the distance from the shoe store to the movie theater. I'm going to use the letters here. So I am given that AB equals CD. That's given to me. I'm told that. Now, just like when I had the last one with angle addition, I'm now going to do some segment addition. AB plus BC equals AC. And then I can also do BC plus CD equals BD. That is segment addition. Now, substitution. I can put AB in for CD. So now I'm going to rewrite the second one. BC plus AB equals BD, and that would be substitution. And then the last step, I'm going to circle it. I have BC equaling AB plus BC, and I have AC equaling AB plus BC. Therefore, I now can say AC equals BD by the transitive property. Solve this for B. Give a reason for all steps. If I multiply both sides by 2, that gets rid of the fraction, and that's the multiplication property of equality. Then, remember, I'm trying to solve this for B. If I divide both sides by H, that would be the division property of equality. I like this page a lot more because it then gets into the properties, and all you have to do is name what property happens. So if angle 6 equals angle 7, and angle 7 equals angle 6, that's just flipping it around, and that's known as symmetry. JK equals KL, KL equals 12, therefore JK must equal 12. That is transitive. Angle W equals angle W. This is the one that most people will forget. It's called reflexive. And the last one is symmetry again. Anytime I'm flipping it around the equal sign, so AB equals BC, then BC equals AB. And that is it. Your homework assignment. Please talk to your teacher if you have any questions, and good luck.